Hello and welcome to this R tutorial. Here we are at the final round of regression with our final regression model, random forest regression. In the previous section we saw the decision tree regression model, so if now the decision tree regression doesn't have any secret for you, then you will perfectly understand random forest regression. Because a random forest is just a team of decision trees, each one making some predictions of your dependent variable, and the ultimate prediction of the random forest itself is simply the average of the different predictions of all the different trees in the forest. And actually at the end of the previous section about decision trees, I asked you an enigma. The enigma was, knowing the result we got with one tree, what would be the result with 10 trees or 100 trees or 500 trees in terms of visualization and in terms of prediction. So I hope that after watching the intuition tutorial made by Kirill, you actually asked yourself this question and try to predict what's going to happen here with random forest regression. So let's find out about that. We're going to build our random forest regression model and see what happens. So let's do it. We're going to start by selecting the right folder as a working directory. So it's in part 2 regression. And here is the final regression model we were building, random forest regression. So let's go inside. And that's the right folder we want to set as a working directory with the position salary CSV file. So let's click on this more button and set as a working directory. All good. And now let's take our regression template to build this model efficiently. So we're actually going to take everything from here to the bottom, but we will only include this code section to visualize the regression model result, because you understood that the decision tree regression model is a non-continuous regression model, and since random forest is a combination of decision trees, then it's a combination of non-continuous regression model, and intuitively we can guess that the random forest regression model is not going to be continuous either. So since this code doesn't work for non-continuous regression model, we will actually use this one that works perfectly for it. So I'm going to copy this, paste that here, and remove this section that is non-appropriate for non-continuous regression models. Here we go, and now the template is ready. Let's change the basics. Let's replace here regression model by random forest regression, visualizing the random forest regression results and fitting random forest regression to our dataset. Okay, great. So now let's build a model, which is in this section here. So let's remove this, and as usual we're going to import the right library for the job and then use a function to build our random forest regressor. So the package we're going to import is called random forest. So for those of you who don't have the package installed in your packages here, well, you can check it out. Mine is already installed because I used it before, but I'm going to write this line here for those of you who need to install it. So install.packages, parenthesis, and in quotes, random. So no capital R, but then capital F-O-R-S-T. All right, random forest. And so I'm not going to install it because mine is already installed, so I'm going to put that in comment. But if you want to install it, you just need to select this line as I just did and press Command and Control plus Enter to execute it. And this will install the package properly. But here I'm going to put it in comment by pressing Command plus Shift plus C. Here we go. And now what we have to do is to add this, library random forest to actually automatically select the box here to import automatically the random forest package when we execute the whole code or the section. So that's important. And now time to build the regressor. So let's do it. We're going to call regressor as usual to keep things simple, then equals. And now the function that we're going to use is also random forest, written the same. And so now let's add some parentheses. And now let's press F1 to have a look at the arguments. Okay, so the arguments are here, and the first argument is data. But as you can see, it specifies that it's an optional data frame, and we could use this argument to build our regressor, but we're going to use the main arguments to specify, the independent variables on one side and the dependent variable on another side. And to do this, we're going to use these two arguments, x and y. So x will contain the matrix of features, that is the independent variables, and y will contain the dependent variable vector, that is the salary column. So let's first input these two arguments. So the first argument is x equals, and so we have several ways to take our independent variables. So one of the way is to take our data set here and then choose the right columns of the independent variables. And you know our data set is composed of two columns. The first column indexed by 1, which is the independent variable column, and the second column indexed by 2, which is our dependent variable column. So here we need index 1 because we want to take the independent variable. Alright, now next argument. The next argument is y, the dependent variable vector. And now, as you can see, y is expected to be a response vector. It's actually a vector. And here it's expected to have a data frame. So by using this one index into brackets here, I actually import a data frame. But here, to get a vector, I actually need to use another trick, another technique, which is to use the $sign and then the name of the column, which is, of course, salary. And that will give me a vector.